Greetings, my name is Shuo-Chuen and I'll be presenting on my research project entitled Catalytic Isomerization and Hydroisomerization of Fatty Acids over Hierarchical Micromesoporous ZSM35. Just a brief introduction on this topic. The catalytic skeletal isomerization of fatty acids to branched-chain fatty acids BCFA is important in the application of biodiesel because the addition of BCFA to biodiesel helps reduce the cloud point and also enhance its stability. In a few papers, zeolites were stated to be the potential catalysts used in isomerization of fatty acids. And among these zeolites, it was stated that ZSM35 fluoride zeolite can be efficiently catalyzed during the isomerization of fatty acids. Moving on to the problem statement, ZSM35 zeolite shows promising results for isomerization of oleic acid. However, fast deactivation of catalysts occurred due to minimized accessibility of active sites and also restriction of diffusion due to long microporous pathways. In this case, hierarchical zeolite catalysts may be able to solve the problem, but the use of hierarchical zeolite catalysts in the isomerization and hydroisomerization of vegetable oil, especially palm oil, is still uncommon. Therefore, the objective of this research is to study on the preparation method of microporous and hierarchical zeolite catalysts, and also to study and correlate the physiochemical properties of ZSM35 catalysts and their performance in isomerization and hydroisomerization of vegetable oil. In the methodology, a project flow was prepared. Moving on to the results and discussion, Table 4.1 and 4.2 were prepared in comparison between the catalyst porosity and acidity of three different types of zeolites, namely ZSM35, ZSM22, and also ZSM5. And from this table, it can be observed that the acidity of ZSM35 is higher compared to the other two. In the study of the physiochemical properties of ZSM35, 4 correlation plots in terms for the ZSM35 porosity and its acidity were plotted. And in the figure, no direct relation can be observed. Next, in the study of the physiochemical properties of the ZSM35 and its catalytic performance, correlation plots in terms for porosity of the ZSM35 and also the conversion and selectivity were plotted. And yet again, from the figures, no direct or obvious relation between the porosity and the conversion and selectivity can be observed. Lastly, Table 5.3 was prepared in comparison between the three zeolites mentioned earlier in terms of their porosity and also their selectivity. And in this table, it can be observed that ZSM35 has a higher selectivity. In conclusion, after the literature review, in the synthesis of hierarchical zeolite catalysts, top-down approach is incapable of controlling mesoporosity well and may suffer material loss. Therefore, bottom-up approach is more preferred. Next, in the study of the physiochemical properties of catalysts, no direct correlation between catalyst porosity and acidity was observed. And among the comparison between the three types of zeolite, the SM35 shows higher value of Bronsted and lowest acidity. And lastly, in the study of the physiochemical properties of catalysts and their catalytic performance, yet again, no direct correlation between catalyst porosity and the conversion was observed. And among the comparison between the three types of zeolite, ZSM35 shows a higher selectivity. As for the future recommendation, a more in-depth study should be conducted on the correlation between the physiochemical properties of catalysts and also the catalytic activity of the catalyst. And also, to further study the effect of catalyst acidity towards selectivity, yield, or conversion of fatty acids. And lastly, I'd like to thank my lecturer, my supervisor, Dr. Wong Kalun, for his patience and guidance throughout the process of me conducting this research. And furthermore, I'd also like to thank the course coordinators and Xiamen University Malaysia for providing me the chance to conduct this research project. That's all from me. Thank you.